Hello and welcome to Fresh Thinking by Snowden Optiro, a podcast where we delve into the technical aspects of the mining industry. My name's Tarrant Elkington, General Manager for Snowden Optiro. I'm joined today by Zhang, who is a Senior Consultant here for us at Snowden Optiro and extensive experience in resource estimation across a lot of commodities and styles. So great to have you here, Greg.
Thank you, Tarrant. Thank you.
The topic of today's podcast is around a presentation that Greg gave in recent months titled "What's the Industry Standard in Mineral Resource Estimation?" Where he and a colleague in Glacken looked at a number of resource reviews that were completed, and came up with some trends on the topic. And I think it's something that's really relevant and interesting for people out there to hear about. So, Greg, maybe you could share a little bit around the motivation for doing this presentation.
Oh, yeah. So this is one of the presentations I gave earlier before at AEGC 2025 earlier this year. So the initial is that since we're working for a consulting company, and both Ian and I reviewed a lot of projects across different commodities or deposits, and also we run the resource estimation at the same time. So I think it's a very unique position, because we can see a lot of practice in the industry. At the same time, we also run that from our in-house, and because we are kind of independent experts. So with that unique perspective, I think there's a value if we can discuss what are the common practice nowadays, because this industry does evolve. It's not static for many decades. It changes every day, and slow or fast. And I think there's value if we can have a look, give it a snapshot, and then maybe after a couple of decades we can look back and do the comparison. So that's the motivation.
And what do you think the standards actually? Why do the standards matter? Why should we set a standard for this?
So the reason is that I think this industrial standards is somehow abused, and whenever people saying, "Look, this is industrial standards," it's a very broad concept, and what precisely are you talking about, and based on what? So that's always not very clear. And in here, we're trying to give a description of this industrial standards based on our experiences, and we're not trying to define the industrial standards, more like describe what we see, we think it is nowadays.
So I guess maybe the best way to do it is to step through a couple of the aspects and see what you saw out of that process that you went through. So like most things, I guess we start with the data, right?
Yes.
The data's bad, then the estimate's going to be bad. So what have you seen in terms of the data?
Right. So, as you know, whether it's data science, whether it's geostatistics, so data, good data especially, and big number of data is always what we need, what we like. And without the good quality of the data, none of those simple or complicated algorithms wouldn't really work, or wouldn't tell you anything you don't know. So, as of the data quality, and we specifically, when we review or run any resource estimation, we would look at a few aspects. So, for example, whether your database management system, whether it's in Excel or whether it's in a commercial level database software, because the advantage of the nowadays commercial database software is that it will reduce the manual handling to the bare minimum. Everything is transferred in the digital format, and that reduces the human errors. And occasionally we look at some projects with a very prolonged history, and even some of the logins was handwritten, and that makes it very hard to even just read, or or even just to transfer that into the to make it to get any useful information from that. It's very hard work. So that's one thing. And then the second thing is when we look at the database, we also would look at whether there's any missing values, inconsistent codings, and because again, a lot of mining projects they get very long history, probably have gone through many owners, and every mining company they probably have their own logging codes. They would call the same thing in a different name, and to make it consistent, to make it useful even for the downstream workers, for example, for us to do the domaining or to even just group the data to do any meaningful analyze. That's a big part of the work. And on top of that, there are a couple scandals. Maybe you have heard or you haven't heard about it. Is that one of them is a BRIX scandal where people would spray this gold on the core and fake this huge potential gold deposits, or like in recent years, one of the mining company called Red Pine, the MD forged the assay results, and that so he can manage or inflate the share price in a very short time, but based on the unrealistic results.
Yeah, so I guess that there are some pretty extreme results, but I guess you see a lot in the not in that sort of that extreme, right? You see a number of cases where the data is just not quite as good as what it could be, and there's ways that you can try to mitigate that. All right.
Yeah, that is one of the common fight we have every day. Like when we have this messy database, how can we clean that up, extract useful informations? Then we can move on from there.
What about QAQC?
Yeah, that's the next very important step. That once we extract the useful information from the raw database, we also want to make sure those data is representative. So how do we make sure it's representative? It's QAQC, quality assurance and quality check, where we would use various, for example, CRM, also duplicates to make sure that the data are telling us some consistent story. And that's a topic where it's one of those common techniques or the typical workflows nowadays. But the thing is, we can still see some projects where it's lack of QC data, and in that case, for our internal policy is that if this project is lack of QC data, then when we think about the classification, it wouldn't get anything better than inferred, because fundamentally you just have no confidence about the data quality itself.
Yeah, I guess the QAQC or this like standards and duplicates, there's typical standards right now that we sort of expect insertion every X number of samples, right?
Yes.
But also, like, is there anything that you've seen on, even if, like, there's one thing to follow that standard, but do people actually follow through with if those samples actually show anomalies, or if they show things of concern? Are people following those up or addressing them or trying to understand them further, right?
Yeah, that's a good point. And so it is very common, or you should even expect that there won't be perfect match for your data set when you compare that to the certified reference material, or short for CRMs, or when you compare your duplicate data with your mine data, you wouldn't find one-to-one relationship. There will be differences. But the thing is, all those differences are telling you a part of the story. Whether you're having something wrong with your sampling stage, whichever stage it is, or there's something wrong even in the lab. Maybe there's a hygiene issue. So all those data, all those the differences, they're telling you the very useful information. So you have to follow up with those differences and further investigate to better understand how that works, how you could improve the data quality and make it more representative.
Very good. So moving on from the QAQC, maybe the next step is the understanding the geology and the domaining of the deposit, right? So what are some of the things that you're seeing at the moment in that space?
So when we talk about after we got the representative data, now we start to think about domaining, whether we're trying to capture the geology, whether it's just the lithology itself, the alteration, or the structurals. They're all parts of the geology. And once we find some consistency in there, we would do the domaining, and we would group the data, essentially just to make sure that the similar data are going to be grouped up together for the further analysis. And this domaining, I think, is the most important part of this entire workflow, because the way you group the data itself actually reflects the fundamental understanding of this ore body. And I had this dummy example where I had just a couple samples and showing people how this domaining could affect the global level of the statistics and also the later on the resource estimation. But before we go into that part, once we've done the domaining, probably 10 years ago when we talk about domaining, people are always thinking about, we want to digitize the strings, whether it's on paper or in the computer. Then we want to connect all those strings on the section basis and link them up. Those solids represents our understanding of the domaining. But then the implicit modeling came, and which is represented by Leapfrog or data mines, data mine Geo. But no matter what software you use, it's just one of the tools that you use to reflect your understanding. So implicit modeling can be a very efficient tool, but we've seen so many bad practices where by those supposed to be smart algorithms, it creates a lot of blobs that trying to capture every single high grade. And that is not a reflection of the geology understanding. And that's not even a reflection of the just as numbers. So when we use those kind of techniques, we need to be aware that what do we want to domain? That's always the fundamental questions.
No, absolutely. And so if we move on from the domaining step to the estimation itself, the statistics and the estimation, what are some of the things you found in that space?
So once we get some domaining we are happy with, then we move on to the data analysis. So we're trying to understand the data better, whether it has some consistencies, or we always use this big word called stationarity. So whether there's enough stationarity in this geology domain, or whether we need to further separate that and create some other estimation domaining. So it depends on which type of the commodities we're talking about. For the precious metals, for example, the gold, we probably want to, always want to have a look at the grade itself. Probably want to separate the high grade from the low grade, even within the same geology domains. And then in the bulk commodities, for example, iron ore deposit, maybe we can define the geology domaining by the stratigraphic. And after that, we might think, look, maybe in this strata, there's not enough samples to get any meaningful analysis. So we want to probably group some of them together based on the spatial locations and the statistical similarities. Then we would group them together, would analyze, whether it has a lot of variability or it's consistent enough to move on. And then we would do the variogram modeling to assess the continuity, the grade continuity, for example, and to further use that to validate or check whether our geology understanding is correct. Because for different commodities, we have different kind of expectations. So the bulk commodities should overall have better continuity than the precious metals.
And so the estimation side, what are you seeing in that space?
So the estimation side, I think the industrial standard has moved. I was reading this monograph from a conference back in 1999, and back then people were still talking about whether we should trust or use kriging itself, because back then people think this kriging is a black box. Like how did you actually solve all those matrix to get the sample weights? And but nowadays, if you look at it, probably over 60 and 70% of the projects were done using either simple kriging or more often ordinary kriging. So we had this a small survey done, and earlier this year we just downloaded all the ASX announcements for that March of this year, and we're trying to analyze, do the counting, see how many estimation has been done using what kind of the methods. And turns out over 60% used ordinary kriging, about 20-ish% used inverse distance, and 20 years ago, inverse distance was the mainstream, ordinary kriging was a minority. And now, ordinary kriging is definitely the major stream, and with quite some inverse distance, and plus with some conditional simulation, some MIK, or with some nearest neighbor. So apparently, the trend, the pattern has changed.
Yeah. Okay. And do you? I guess maybe we'll talk to where you might see things going in the future, but I guess the other point here to look at is around a couple of points around classification. What are you seeing in that in classification?
Yeah. So before even we talk about classification, I would spend usually half of my time on the project basis to do the validation. So validation, I think, is very important because with nowadays all the mass estimation with the proper techniques of the scripting, you could make that happen in minutes level, and with the powerful computers, as everyone has nowadays. So then the problem I think we should really focus on is whether we have optimized our parameters, or whether it's domaining or estimation parameters, make it as best as we can within this time frame. Then that's where the sensitivity estimation steps in. And that's why I think it is important for us, the resource geologists, to get this skill to streamline our workflow and spend as much time as we can to do the validation and to find the best estimation method or the estimation parameters or even domaining, and then we can deliver the best model we can. And then after that, we would start to think about the classification. We want to whether it's qualify or quantify all those quality of the estimation or the uncertainties. And under that topic, we get all sorts of the tools. And whether we're simply using the kriging variances, or we could use more complicated methods, for example, conditional simulation, or even use some machine learning methods, for example, the convolutional neural networks, where we could also create a lot of versions of the estimation, then we can ensemble them and then assess the uncertainties.
Oh, that's interesting. And do you? I guess the final thing is really around reporting and RPEEE, and that's probably an area that's changed quite a bit in the last few years, right?
Yeah,
So,
yeah. So as of the reporting, I like to split this into two parts. One is resource reporting. It's simply report our model with whatever the constraints and with some cutoffs to say, look, those are the metal or tonnage and average grade we would expect if we mine the whole lot or some part of it. So so it sounds simple, but in the reality, we've seen 2 out of the 60 projects, it has some material mistake in this area. In each of those 2 projects, over 500 million US dollar of dirt has been over-reported or overstated. So the reason for that is very simple. You have some you have multiple versions. You've got to use RPEEE to constrain the resources, or you use the wrong version of the pit shell to constrain the resources. So that's why, or you've got to deplete some part of the models. So that's how you got those mistakes. So to me, I think it doesn't happen all the time, but once it happened, it can be very material. So to me, I think the best practice is to write up a memo and make it part of the routine that put all the key informations in there. For example, what's your block model name? What's the date? How large is that? How many records are in there? All those fundamental information, and also expected tonnage grade curve and what files, what constraints you have been used. And then whenever you deliver that to our mining engineer colleagues or other stakeholders, they can easily pick it up and find out how to reproduce your numbers with this set of the files. And RPEEE, you are the expert, so can you tell us about it?
Well, no, but I'm not sure I'm the expert, but I guess from my understanding, the trends over time is like maybe over the last 10 years has been, even though the code itself hasn't changed, I guess the interpretation of the code around this has changed and will probably continue to evolve. And so now, probably 10 or so years ago, it would be very common for resources to be reported just unconstrained. And by unconstrained, it could go to the center of the earth at 0.2 grams per ton, and maybe be considered to be to be included in the resource. And now typically people would run a pit optimization or some other stope optimization, some other methodology in order to demonstrate that there's a possibility that this material can be extracted. So I would guess, and you correct me if I'm wrong, that the dominant practice would be not to constrain, say 10 or 15, 20 years ago, and now the dominant practice probably would be to do that constraint. So I think that's a change now.
At least that's one of the fights we have every day. We're trying to push as hard as we can to ask every of our clients to run the pit optimization. I think probably even a couple years ago, most of the models we reported, it's at the best case, it's constrained by certain RL. People are saying, look, above this RL, those are the resources, and below that, we call that potential. And now we're saying that more and more people or companies, they start to accept this idea. Maybe we should make it a little bit more realistic. And to me, I think that's definitely a good practice for everyone.
So I think that probably takes us through most of the aspects to look at. Was there any other? Did I miss any on in the hit list?
Yeah, I think there are some new trends that we could talk about because we've seen how this industrial standard evolved.
Yeah.
And now based on this trend, what's the near future?
Yeah, absolutely. What do you? Well, I'm keen to hear from you as to what you see those. I think in your presentation you gave a few. So maybe at a high level, what are those?
Sure. Sure. So we've covered the main aspects of this MRE workflow. I think as of the database, people are moving all towards the commercial level database system, and as of the domaining, people are embracing this implicit modeling more and more, and it's just it's a tool. It's a tool. Whoever going to use that better to understand, have a little bit of understanding about how that tool works, and then when you come to the EDA or the estimation, I think with high computation power, it is important for people to start to streamline things and spend more time for the sensitive estimates. Those are the near trends, I think. And then the thing I think, or I have observing, is that the large companies or the big mining houses, they put more and more effort on those nonlinear estimation techniques. They're making that into their daily workflow. Whether it's LUC, multivariate LUC, MIK, conditional simulations, or those are for the great uncertainty, and people even start to think about the use a plurigaussian or hierarchy truncated plurigaussian to model the geology uncertainty. So that becomes more and more often mentioned. We can start to see those case studies, papers, and then to me, I think the machine learning is also start to get involved. We start to see some studies, compare this machine learning algorithms with our traditional geostatistics, what benefit we can get from those machine learning algorithms. Again, with the change of this computation power, a lot of things become possible. And if you read the papers about these machine learning algorithms, a lot of them got developed or mentioned, proposed back in 1960s or 70s. They're just as old as kriging algorithms. They're not something new. But nowadays, it starts to get used in the practice, in the real-life projects. And I think that's exciting, and that's part of the new trends, I would say.
Excellent. Well, yeah, I think it's great to actually take a step back and try to understand the standards, and sometimes defining what those standards in helps us to understand a little bit about where we're going and how they'll continue to evolve. And I think it's always an interesting thing being in our industry and doing the things that we do, is you got to help move that standard forward, right?
Exactly.
So thank you very much for your insights today, Greg.
Thank you, Tarrant, for having me. It's a great discussion.
Great. Okay. Thank you very much for joining us here on Fresh Thinking by Snowden Optiro. If you enjoyed our podcast, please subscribe to us on any of the major podcast platforms, and so that you can stay in touch with us for future podcasts where we delve into other aspects of the mining industry. Thanks very much.